The last law that we are going to deal with in this unit is called Avogadro's law, so it's named after the same guy who already has 6.02 times 10 to the 23 named after him. This is a really easy concept to understand, I think. If you have ever blown up a balloon, you already have a reasonably good appreciation of what Avogadro's law is. But let me state it using the balloon example that I have been using in previous sections. So let's say that I have a gas in a container. Let's say that it's a balloon. The balloon has a fixed number of gas molecules or atoms inside of it, right? Who knows how many there are? Maybe there are 10 million molecules, maybe there are 3 moles worth of molecules. It doesn't really matter. You have put in a fixed number of gas molecules, and let's assume that those gas molecules can't escape. What Avogadro's law says is that if I add more gas molecules to my container, the volume of my container will go up. And conversely, if I reduce the number of gas molecules in my container, if I let some of the gas molecules out, the volume decreases. And again, as I said, anyone who has ever basically filled up a balloon, blown up a balloon, you have basically done this, right? You have added more gas molecules to a gas container and the volume of your balloon increases. And if you let some air out of the balloon, the volume of your balloon decreases. So this may have been earth-shattering news back in Avogadro's day, but we pretty much do this at every birthday party that you probably have ever thrown. So what Avogadro's law says is that the volume of a gas is proportional to the number of moles of gas, which is really just saying the volume of the gas is proportional to the number of molecules or atoms of gas in the container. Mathematically, you say that volume is proportional to the number of moles. Don't worry so much about the math. The formula, which I would give you on a quiz or a test, is the initial volume divided by the initial number of moles is equal to the new volume divided by the new number of moles. And I believe I have an example problem on the next slide. Nope, not quite yet. So just to drive this point home, the volume of the gas is proportional to the number of moles of the gas. Imagine that I have a balloon that has 10 million oxygen molecules in it. What Avogadro's law says is that if I double the amount of oxygen molecules, the volume of my balloon is going to double. And it doesn't really matter what the units are when you're counting the molecules. It can be number of molecules, it could be moles for all you care. If you have 1 mole of helium in a balloon, and you double the amount of helium, in other words, you put in 1 additional mole to give you 2 moles total, the volume of your balloon will double, according to Avogadro's law. Here is the sample problem. You can pause at any point and try to solve this on your own. The problem says that you have a 4.8 liter sample of helium. So pretend you have a helium balloon and the volume of your balloon is 4.8 liters. Inside of your helium balloon is 0.22 moles of helium atoms. So the volume of the balloon is 4.8 liters. The amount of helium that's in the balloon is 0.22 moles. And then the question is, how many additional moles of helium gas must be added to the sample to obtain a volume of 6.4 liters? So basically, you start out with 0.22 moles of helium, and the volume of your balloon is 4.8 liters. And they're asking you, how many more moles of helium do you need to add to increase the volume of your balloon to 6.4? And again, assume that the temperature doesn't change, assume that the pressure doesn't change. So to do this, we need Avogadro's law, we need the formula, and we need to know the pieces of the formula. We need to know what V1 is. V1 is 4.8 liters. We need to know what N1 is. N1 is 0.22 liters. We need to know V2, which is 6.4 liters, and we're trying to figure out N2. So there's the formula for Avogadro's law, and we basically plug in all of the relevant numbers, and it turns out to be 4.8 liters, which is V1, divided by 0.22 moles, which is N1, is equal to 6.4 liters, divided by we don't know how many moles. And so if we want to solve for the question mark down here, again we cross multiply and divide, and by doing that we to figure out what the question mark is, it's 6.4 liters times 0.22 moles divided by 4.8 liters. And if you look, we again have liters in the numerator and the denominator, which means they cancel out, and the only unit we're left with is moles, which is what we're looking for. And so if we do 6.4 times 0.22 divided by 4.8, we get 0.29 moles. What this means, and there's a little trick in this question. The question, or what this number means, is that basically, if we have a helium balloon with 6.4 liter that has a volume of 6.4 liters, there must be 0.29 moles of helium inside of it. But the question, so this isn't the answer, however. It gets us toward the answer, but it's not actually the answer. Because if you look at the question, it says, how many additional moles? And I put additional moles in purple there. So what they're saying, this is how many moles total. What the question is asking is how many additional moles? Well, you already started with 0.22 moles, and you need to have 0.29 moles in the helium balloon to have a volume of 6.4 liters. So how many additional moles did you add to your 0.22 moles? Well, it's the difference between 0.29 and 0.22. So the answer to the question that they're asking is actually 0.29 moles of helium, which is how many moles of helium you have in the balloon at the end, minus 0.22 moles of helium, which is how much you had at the beginning. So the answer to the question is actually 0.07 moles of helium. And so that's it for Avogadro's law. Avogadro's law basically tries to tell you what the volume of your balloon will be if you alter the number of moles of gas that are in your balloon, or if you alter the number of, or if you alter the volume, how many moles of gas are going to be in your balloon.